Good afternoon, everyone, and welcome to this CWNP webinar on 802.11ac analysis, and welcome to the beginning of the week of 5 webinars. That's right, this week we'll have 5 different webinars for you on 5 different topics throughout the week, ranging from 802.11ac analysis today through to dealing with some Kali Linux analysis and demonstrations. So we'll take a look at how that distribution of Linux can be utilized for us to accomplish a lot of things in relation to Wi-Fi. But here today we're focused on 802.11ac. Now our goal is to keep the primary portion of the presentations down to about 30 to 40 minutes each day, so we don't take up a lot of your time, but we'll also have time for question and answer if you'd like at the end. So let's jump right in to talk about 802.11ac analysis because it can be somewhat complicated. First thing I want to talk about is CWNP certifications. Most of you probably know CWNP well, but just to make sure you have an understanding of who we are a vendor-neutral knowledge and skill set certification company. So basically, we ensure that people can understand the wireless technologies and use them for their purposes within their organizations. So we offer certifications ranging from very entry level all the way through to expert. At the entry level side, we have the CWTS, the Certified Wireless Technology Specialist. This is an individual that may be very heavily focused on sales or supporting small wireless networks that doesn't need the advanced knowledge that comes through our other certifications. CWNA is our entry level into the full track. So with a CWNA certification, you are prepared to go further and gain knowledge and certifications in design, security, and troubleshooting, which are the CWDP, CWSP, and CWAP certifications. And the CWNA certification really helps you to understand Wi-Fi from an enterprise perspective. So you begin to go into more depth into the different architectures of wireless, such as controller-based architectures, controllerless architectures, cloud-based architectures, and all the rest that are used in Wi-Fi. And then you get into the very detailed information with CWDP, SP, and AP to learn more about what these certifications and these technologies offer. And then, of course, the Certified Wireless Network Expert is the elite of the industry. So this is where you're dealing with the fact that not only have you passed CWNA and all 3 professional level certifications, but in addition to all of that, you have also passed a review of the Board of Advisors. This is a panel of 6 individuals that look at your application and determine whether or not to approve you for that status. Now, to even apply, you have to meet certain qualifications. So you need to have several years of experience in the industry. You need to have been involved in helping build the industry, and we test that through the fact of, are you creating any content out there? So if you created white papers or blogs or e-learning courses and videos and things like that. So all of that is part of the whole process now. And of course, you can learn more by going to CWNP.com. Go to certifications in the upper left-hand corner, and you can learn about all of our different certifications. Now, I also have some other exciting news for you today. We have the CWNP September conference coming up in September on the 22nd, 23rd, and 24th, and you can learn all the details about the conference. There are several different industry-known speakers that are going to be there presenting on different and very important topics. Our focus here is 15 years of wireless. Not that wireless has only existed for 15 years, but that thanks to the release of 802.11a and 802.11b, wireless really began to take off about 15 years ago. And so we're into 15 years of very heavy use of wireless from an 802.11 perspective, and we're going to look back a little bit, but mostly we're going to be looking at what we have today and looking forward, and a lot of great presentations will be there. So you can visit cwnp.com/wireless conference to learn more, but here's an important part about being part of this presentation today. And that is that if you use the coupon code of Wi-Fi 100, that's WIFI 100, you actually get $100 off the CWNP conference registration. So if you want to attend that, it's a great getaway. If you work in the wireless sector and you like to attend conferences that are really focused on what you're doing, then I think you'll find a lot of great value out of this conference. So make sure you check that out at cwnp.com/wireless conference, or you can just go to cwnp.com and you'll see that there's an ad right on the main page you can click to go into more information about the conference. And always remember the Wi-Fi code or the coupon code of Wi-Fi 100, which gets you the $100 off the conference because you've attended this webinar today. So what are we going to be talking about with 802.11ac analysis? Well, first of all, we're going to talk about 802.11ac analysis issues. And the issue with the 802.11ac analysis is that, well, it's not as simple as just saying I'm going to do it. So you need to make sure that you understand some of these issues, and we'll talk about those. We'll talk about hardware and software that you can acquire to do the analysis, and we'll do a couple of demonstrations. We will, if time permits and everything cooperates, because these are going to be live demonstrations. I haven't pre-recorded anything. We're going to really do it. I'm sitting in my lab, and we're going to really do this. So let's all keep our fingers crossed and hope we can really do it. So we'll do a couple of demonstrations of both capturing using an adapter and capturing using remote capture with an access point. So we'll take a look at both of these and see how they work. And then, of course, we'll deal with any questions you might have toward the end of the presentation as well. Let's go ahead and talk about the issues with 802.11ac analysis. The first thing is obviously getting the right hardware. You can't just use any hardware you want. So we're going to come back to that a little bit later on, but there's a link between getting the right hardware and the complexity of the environments. And we've already seen this with 11N. So with 11N, you have the issue of single stream, dual stream, and triple stream, or 2x2, 3x3, 1x. So in other words, one spatial stream, two spatial streams, or three spatial streams. We already had that in 11N. We have that in 11AC too. So that's an issue of complexity that's there. The difference is 11N has been around for a while. And so there are several adapters you can get your hands on to do protocol analysis pretty easily with 11N if you're trying to do kind of the mobile laptop analysis configuration where it's easy to move around and do analysis. Now I say easy because, you know, we can use an 802.11n access point that we carry around with us with some kind of battery power or something and use that to do our packet capture that we then analyze in our software. So we can do that with 11N, we can do that with 11AC, but that doesn't mean it's easy to move around. Now, we do have adapters right now for 11AC that are 2x2 that can do analysis for us, and we'll talk about that and the different software that works with it. And then we have forthcoming, eventually we'll have 3x3 adapters, but right now we're really kind of limited there. We don't have a lot of that, so we kind of have to do any 3x3 analysis we want to do with either special hardware, as vendors decide to release those, or by using an access point that can do packet capture for us. And so we will look at doing packet capture on an access point. But the good news is that most of the AC clients that are currently out there are 2x2, so you can probably do some significant and useful protocol analysis still with just a 2x2 adapter in your client system. But eventually we'll get the 3x3s and we'll be good to go there as well. So just know that right now there are some concerns and issues with that, but we'll deal with those, and I'll talk more about getting the right hardware in a few minutes. But the first thing I want to do is make sure we do a quick review of understanding 802.11ac enhancements. So we have talked about this in webinars in the past, therefore I'm not going to dwell on each of the upcoming slides for a very long period of time, but I do want to go through and review this information again. So first of all, the key with 11AC is it's 5 gigahertz operation only. So we're only working in 5 gigahertz. And so we need to know the channels, obviously, that we have to work with. And you'll see some interesting things. I've opened packet captures that were created on access points in protocol analyzers. And then all of a sudden, the protocol analyzer is telling me in the radio tap header that it is a packet that was captured on channel 178. Figure that one out. So clearly there are still some issues with decoding 802.11ac packets that cause some confusion to some of the protocol analyzers. And yes, by the way, that was with the absolute newest version of that particular protocol analyzer literally just yesterday. So it does happen. So you do have the concerns over some oddities that are still happening there, but we're beginning to get better support. So the first thing is to know the channels. And because we're in 5 gigahertz, you know, it was simple in 2.4 gigahertz, right? You hoped at least that in your environment you were on 1, 6, and 11, generally speaking. And so it made things a little bit easier when you were doing protocol analysis and packet captures. Now in 5 gigahertz, there are a lot more channels that might be being utilized. So the first complexity is all of the different 20 megahertz channels and whether they're available, whether they're not. For example, 802.11ac in the appendix added the numbering for channel 144. So we have that extra channel that was added. Is it used by adapters? Not many yet, so there's not a lot of use of that out there. Most of the time, your client adapters, you're going to see them supporting 36, 40, 44, 48, 149, 153, 157, 161, and maybe 165. And then going back, they may support 52, 56, 60, and 64. And then you'll have hit or miss with the you need to extended. So your adapter, you need to know what your adapter supports that you're getting to do packet capture to make sure that you can actually capture on the channels you're using. So the first element with 802.11ac protocol analysis is understanding there are just more channels. But the second one is that there are now, well, typically the way we use it today, 3 different combinations or channel usages you might see. So you'll see a 20 megahertz channel, you'll see 40 megahertz using 2 20 megahertz channels, and you'll see 80 megahertz using 4 20 megahertz channels. Now, probably in an enterprise deployment, you're going to see mostly 40 megahertz. In consumer deployments, small businesses, things like that, we're already seeing 80 megahertz channels because that's the default for a lot of devices. And what do they do in small businesses and in consumer home networks? They just leave everything at default, right? So you see a lot of 80 megahertz channels there, and it's probably not a big deal in those environments, but you may find it, depending on your consumer space that you're in, maybe you're in an apartment or something like that, or you're in a housing development where the homes are real close to each other, then 80 megahertz may not be the best choice for you. You may be able to get better throughput out of a 40 megahertz channel that's less active and congested than an 80 megahertz channel where you're doing extra overhead to just throttle back to 40 megahertz channels for so much of your communication anyway. And you'll understand what I mean by that by a future slide. So the first thing, just know the channels, know that there's complexity in the way the channels work, and know how your protocol software, your protocol analysis software works with the complexity of those channels. So does it automatically, if you say capture on channel 36, does it automatically see that there's 40 megahertz in use and capture 36 and 40? In other words, the bonded channel, the 2 channels together as one 40 megahertz channel, which we would call channel 38. Does it automatically see if 36, 40, 44, and 48 are all being used to make an 80 megahertz channel and therefore capture on what we might call channel 42, right? So does it automatically do that? That's an important question to ask and to make sure that you understand how your protocol analysis software works. And you can usually see it too when you just look at the information being reported from the radio tap header, things like that. You look at the center channel frequency, or maybe if you look at your VHT operational section in your frame, then you can actually see what's the center frequency for the frame, and you may see that center frequency is indeed what you would get for what we're calling here channel 42. So that's something to keep in mind as well. So you've got to make sure you understand all this channel stuff when you're dealing with protocol analysis here. We're not going to spend a lot of time on this, but yes, 256 QAM is there. We're going to see a connection that uses 256 QAM. So we're going to see it. We'll know it uses 256 QAM based on the data rate and the fact that we know the channel width. And so all that's going to tell us we're using 256 QAM. And the fact that we know the spatial streams as well, I should add. So anyway, we'll look at that. So yes, 256 QAM is there. It gives you your highest data rates. We won't go into that in more detail today. We've also got support for multiple spatial streams, up to 8 of them. We'll be seeing a maximum of 2 spatial streams in actual communications today, but we'll see in the beacon frame that there is the availability at the access point to do 3 spatial streams. So we'll see that kind of information as well. And yes, we can have 160 megahertz channels if we want. I would suggest that we don't want them in most cases. I can't even fathom an enterprise scenario where you'll probably end up getting actual benefit with the frequency space available today that is more important to you than the cost. So I think that the cost to the consumption of so much of the frequency space is to the point where it would make it where it's not worth the benefit of the greater data rate. So it's probably better to stick with max of 80, and most enterprises today are probably going to use 40 unless they're doing high density, and then they'll look at 20 megahertz channel plans. And so I don't think we're going to see a whole lot of enterprises wanting to use 160 megahertz anyway. But the other thing that's important to understand is that the devices right now don't support it. We'll see that too when we do the packet capture. So when we take a look at the packet capture, we'll be able to see, oh no, I don't support 80 plus 80 or 160 megahertz channels. So again, all that in the actual protocol analysis. Improved channel usage. So 802.11ac does have some step-down functions that it can use. And we're not going to explain all of it in detail, but this thing called dynamic bandwidth operation allows it to use an 80 megahertz channel if it's available, but when it's not, to throttle back to 40 or even all the way back to 20 and automatically take care of that. So this is something that allows us to use an 80 megahertz channel when we can get a data frame through at that speed, but if we can't, we can go ahead and communicate the data frame at the slower speed that would be available with a 40 megahertz channel just to get the data through. And so this can be used, for example, if you've got some overlapping cells where maybe one cell uses 2 lower channels for 40 megahertz, and the other cell uses the next 2 upper channels for 40 megahertz, and then both of them use each other's other space for 80 megahertz channels. So you know you've got the overlap. Every now and then, when it's a non-busy time using RTS-CTS, we could use an 80 megahertz channel for some burst of throughput, but time will tell whether this gives us the return on investment that makes it worth it or not, and then that'll become a part of our planning as we actually implement in the real world. Because it's one thing to test in a lab environment with 3 computers, it's another thing to see how this really functions and what kind of overhead it causes in real world deployment. So we do have this option, though it's there in 11AC. And we also have standardized transmit beamforming. Now don't be confused by that. We had standardized transmit beamforming before. It's just there were multiple ways to do it. And so now what we have is we have one way to do it in 802.11ac. And because it requires explicit feedback, we can see that beamforming is available. And actually, beamforming is supported in Wave 1 in most of your devices. You can see it in the frames that it's supported, but what's not supported is multi-user MIMO. And so that's where you're doing beamforming based on multiple users so that you can actually communicate to multiple stations from the AP at the same time. And that's what we see here. So that is something to come in Wave 2, and Wave 2 is upon us shortly. So we're not as far out now as we were when we first started talking about 11AC here at CWNP in our webinars last year, about this time, as a matter of fact. And so now let's talk about hardware and software and then get into the demo. So when it comes to our hardware and software, we need 2 things. We need spectrum analysis and protocol analysis. Well, with spectrum analysis, you know, it's the frequency space, right? So if you have a Wi-Spy DBx that you bought before 802.11ac came out, for example, guess what? It still works for spectrum analysis. You don't even need to update the software, and it still works. If you just want to look at the actual energy in the spectrum, you want to see what's happening and visualize it. Now, if you want the software to use some intelligence and figure some things out, looking at what we might call fingerprinting or some other term for identification, what the actual channels are, and that they are 802.11ac 80 megahertz channels, for example, then you would need to update the software. But the actual spectrum is just what it is. It's the frequency space. You can see the energy. And so you can use your existing analysis software and hardware and actually see activity. But if you want, again, features specific to AC in the software, then the software would need to be updated. The protocol analysis portion, and by the way, let me back off on that for just a second. Yes, there was a new channel 144 added, but it's still within the range of the most spectrum adapters. And so you would have already been seeing that energy in those areas for most spectrum adapters anyway. So then protocol analysis, we need a good adapter. So for current adapters right now, if we're going to do an adapter instead of a remote AP capture, then we're looking at 2-stream. They are 80 megahertz, no multi-user MIMO, and examples, the Edimax EW-7822UAC is a really good one. I'll be using it today. It's very cheap. You can buy it online for $30, so it's not a very expensive device, and it allows you to capture. Another example is the NETGEAR A6200. Now, I've chosen these 2 on purpose because we still have the exact same issue today that we've always had in the past when getting adapters for doing protocol analysis. And that is that some adapters are better than others. The Edimax EW-7822UAC is better than the NETGEAR A6200. Even though both of them support 80 megahertz, both of them are 2x2x2, still we need the better features of the Edimax. So what it comes down to is the drivers and the chipset and what can be done with the software. So for example, when we're dealing with the Edimax, we get a good radio tap header, which is important to us when we're doing protocol analysis, right? So we can see things like noise floor relative. Spectrum analyzer is better, but we can see noise floor. We can see the signal strength. We get all of this information. NETGEAR A6200, for example, doesn't show us the noise floor. And so the thing to check with is check with your protocol analysis software vendor. See which devices they support. And right now, the only one that of the major protocol analysis vendors out there that supports 802.11ac off-the-shelf adapters is Commview for Wi-Fi. Omnipeek is in the process of getting an adapter out there that can be used to do protocol analysis, and they discussed that at the recent Wireless Field Day. So they're working on that, but if you look at their site, you'll see that they don't support any 11AC adapters that are actually adapters right now. Commview for Wi-Fi does, and it supports both of these. But when you look at their specs for what they support, you're going to see that Edimax is far superior to NETGEAR. There are actually 3 adapters that they give full support to and say that they're good to use. The Edimax here, the Linksys WSB AC device, and there's one more that slips my mind. I think it starts with a Z, Zyxel. So that is out there and is also supported. So these are current existing supported adapters you can get right now today and use with Commview for Wi-Fi. And Commview for Wi-Fi has done some other things that are kind of nice. We'll take a look at it and see what it can do there as well. Now, what do I think of using the Mac with the built-in 2x2x2 11AC? As long as you can get protocol analysis software that supports it, it's absolutely fine. And that's the big thing. I'm not picky about the adapter as long as it tells me what I need to see, and as long as it supports the capabilities that I need. But a big thing to watch for is it 2-stream? Is it 3-stream? Is it 1-stream? Is it supported in my operating system? Is it supported in my protocol analyzer? So we've got to look at all of that. Now, another thing to keep in mind is that, again, you can do capture from APs. Now, today, if we get the demo time to do it, we'll be looking at a very inexpensive AP that you can actually do this with, and it's a Cisco access point. It's made for the home and small business market, really the small business more than anything. But okay, I'm one of those weird guys that will spend $300 for an access point for my house. But anyway, the point is, it's the WAP 371, the WAP 371, and just to make sure that you get that right, I've typed it in there to the chat. So WAP 371 is the model number, and so if you hear me say WAP 371, that does not mean that I'm using WAP for wireless access point. That's just the code for this, and I'm saying as quick as I can. I hate the use of WAP for that. But anyhow, the point is that the WAP 371, or WAP 371 if you will, is a small business device, and it does protocol analysis. So it is actually a 3x3x3 protocol analysis capable device. So the software, obviously we have Omnipeek, Commview for Wi-Fi, Wireshark. You can do capture with Wireshark. For example, for 802.11ac right now with Wireshark, I would need to do remote AP capture, but I can do that with Wireshark. So Wireshark can point to that Cisco WAP371 and use it to do the capturing of the frames. Wireshark gives you an awful lot of malformed packet errors when you capture 11AC right now, so do keep that in mind. There are some issues in there with the decoder, but interestingly, it saves all the data correctly, and then if you turn around and open that data up in, say, Omnipeek or Commview for Wi-Fi, everything looks beautiful. So you can use Wireshark to do a capture from your Cisco with remote AP capture, and then pull that information into one of the other tools for analysis if you want to. So a lot of software solutions that are out there, and that means we're ready to just take a look at a demo of actually doing some capture. So the first thing I'm going to do is bring up a little Wi-Fi Inspector tool, Xeris Wi-Fi Inspector, just so we can take a look at our environment. So basically, we can see some things in my lab here that are active. You can see that I've got an active network here, CWNP net, and you can see that I have a Linksys network here. Now, I've just named these Linksys to make it easy to see. So I've got a Linksys 1900-5, reminding me that that is a 3x3x3 11AC device. and I've got a Cisco AP5. That also is a 3x3x3. Both of them 80 megahertz channels. Now, interestingly enough, here in Xeris Wi-Fi Inspector, it hasn't been updated to know the 80 megahertz channel. So if you look over here, you do not see the 4 channels that are being used. You just see 2 channels, and that's okay. I can at least see that it is there, and I see those networks. So the Linksys network exists. It's running there. The Cisco AP, that is the WAP371 that can be used for protocol analysis. And again, it's telling us that all of them are 11N, but they're actually not 11N. And we're going to take a look at some protocol analysis then. Now, first of all, I want to point out that I have the Edimax adapter plugged in right now. So I'm going to go into Commview for Wi-Fi. So I'm using VMware to run a virtual machine running Windows 8. And I have the Edimax Wi-Fi adapter passed through to the virtual machine. So it's a virtual machine setup here that gives us all of this information. So it's configuring the adapter. And then after configuring the adapter, it takes me right into the software. And so here we are in the software. Now, the first thing you'll notice is that we're already seeing some spectrum activity down here at the bottom. Okay, so that's because in addition to the Edimax adapter, I also have a Wi-Spy DBx adapter plugged in. So Commview for Wi-Fi now integrates those. So you can see your spectrum activity at the same time as you can see your protocol activity. And so we're going to use this just in scanner mode here in a second in order to find out what's out there and let this tool do the finding out of what's out there. But first of all, what I want to do is go to Help and Driver Installation Guide. This is the feature in the software that's built in to help you get your driver installed and up and running to actually work. And this just shows you here that I am using the EW-7822UAC. So I just wanted you to see that is what is showing up there. We can see the activity that is going on. What we're going to do is do a quick scan to just see what's on the network, not really worrying about the data is being transferred or not. Now, what you can see up here is the simple filters for this software. So you can filter to see data, management, and or control. Really, to get the picture of what's going on in my environment, I can just look at management and I don't even need data. So we'll just turn off the data. I'm scanning for only half a second on each channel because I want a quick report to tell me what's going on there. And I'm going to go ahead and scan the 5 gigahertz channels only. I'm going to do Uni 1, Uni 2, and Uni 3. So those are the channels that I'm after. So we're looking at 36, 40, 44, 48, 52, 56, 60, 64. Now, why did I choose to do that? Well, because the nice thing with this software is I'm looking right over here and I can actually see that I've only got activity in those areas. So I can clearly see there's not a lot going on, so I'm not going to waste time scanning in those areas. I do see activity in 2.4 gigahertz, but remember, 802.11ac does not work there, right? So I'm not worried about what's going on in 2.4 gigahertz. I'm not going to be analyzing that at all today, so we're just going to look at the 5 gigahertz. I'll go ahead and click on Start Capture, and you'll quickly see that it starts to get information about things that are going on out there as it's scanning through the channels. So it has found that there are things going on channel 36, on channel 149, on channel 161. So we're seeing information out there. And this is some of the same information that we saw in Xeris Wi-Fi Inspector. There's a difference, though, this time. This time, it's actually detecting 11AC. How do we know that? Well, take a look right here. And notice that we see the Belkin, which, by the way, if you didn't know, Belkin now owns Linksys. And so Belkin MAC addresses are in newer Linksys devices, so you'll see that. So this is actually a Linksys device branded, but has a Belkin MAC address. And so we can see here that it has, when you're at 40 megahertz, channel 36 and channel 40, but when you're at 80 megahertz, channel 36 through 48. So that's showing me that information, and I know that's going to be 80 megahertz if it does that. And then the Cisco device, same thing, 149 through 153 at 40, 149 through 161 at 80. And so I already know that, yes, this is an 11AC adapter. That 11AC adapter is actually able to see the 80 megahertz channel width, and it's gathering that information for me. I'm going to go ahead and stop this capture because I have plenty of information to be able to look at and see it. So now if we go to channels, we could see any kind of data that might have been here, but because we only captured management data, we really don't have any information in there to look at. So let's go over to packets and see what we have there. And here we can see our beacon frames. So this will be our first opportunity to take a look at an 802.11ac packet. So we're going to go ahead and go in and let's take a look at the one from the Linksys device first. So this is our Linksys 3x3x3 up to 80 megahertz wireless router, actually. Okay, and so notice that it's configured to channel 36, 5.180 megahertz, and we can see it's 6 megabits per second. What's that tell you? It tells you that the lowest supported data rates in 5 gigahertz are supported on the device, because if it only supported, say, down to 18 megabits per second, we would see this going out at 18 megabits per second. So this has not changed. Well, one of the issues, and I'll just tell you with that device, and I'll tell you by showing you, we'll go ahead and connect to it here. So this is the interface on that particular device. It's a really nice device for doing some 11ac throughput testing and so forth, but the problem is that the firmware that comes with it doesn't give you a lot of control. So if you go into wireless on it, and then after you're in wireless, you edit your network, for example, your 5 gigahertz network here. Notice I can set my channel width. I can set the security mode, which I've intentionally left with no security, and that's just so we can look at packets later. But the point is, there's nowhere in here for me to change supported data rates or anything like that. There's just nothing in the interface that supports that. However, if you go into connectivity, and right here on the basic tab, you'll notice that you can update the firmware. Well, specifically right here where you can choose a file, this is actually marketed by Belkin/Linksys as a device that supports open source. So you can get DDWRT and put it on here and then get access to doing all of that stuff. So if you want to use it as a test device, you can get some good information online about how to do that and get the custom firmware on it. So we can see that it is running there, but if we go and take a look at the Cisco beacon frame, notice that that beacon frame in this case is going out at 24 megabits per second. Okay, so we've got some lower data rates that are disabled on this device. So we can see that immediately there by looking at those. Now this happens to be this WibHu happens to be an Airmagnet 11N device that's in the same area. So we can see that as well. So let's go down further in the beacon frame and see what's in here that's 802.11ac specific. As we go down into the frame, you're going to get to a section that's VHT. So right here, we can see the VHT capabilities. And if we expand that out, you can see things like the aggregated MPDU up to 1 megabyte in size there. So you can see what that actually is. You can see the fact of whether or not we support the short guard interval. We do. But notice we don't support it for 160 megahertz or 80 plus 80. Well, we don't even support those. So that's why we don't support the short guard interval. But we support the short guard interval for 80 megahertz. You can see if you look at space-time block coding, it's not supported for transmit, but it is supported for one spatial stream receiving on this particular device. If we look at the Cisco device, we would see that STBC is not supported either transmit or receive. No beamforming, beamforming is there for single user. Now it says multi-user beamforming is supported. Well, that's debatable. So we'd have to have a client that supports it and test it in order to find out if that's really true or not. It is interesting. You see this a lot when you're looking at 11AC frames. You see a lot of 11AC frames that say the VHT TX-op is not supported. And that's a new power save feature in 11AC. So it's not uncommon for that to not be supported. If we go down further, you can see the MCS sets. And this is really interesting because you can learn from this quickly how many spatial streams are supported. So notice there are 3 spatial streams here. So spatial stream 0, 1, and 2, SS 0, 1, and 2, which notice it goes up to 7. So that's actually spatial stream 1, 2, and 3. Okay, from a human perspective, but from a computer perspective, it's 0, 1, and 2. And MCS 0 through 9 are all supported. Okay, so we're seeing that as well. If we go on down here, an interesting thing in the VHT operation, we can see right there, it's telling me the channel width is 80 megahertz. And notice the channel center, 42. That's what I was talking about earlier. So it says it's 42. The actual frequency is 5210. So if you take a look at a channel map, you will see that that is using all of, in this case, Uni 1. All 4 channels there of the 20 megahertz channels are being used in order to accomplish this 80 megahertz channel. So you can see that information, and all of that is available just in the beacon frame for 802.11ac communications. So now what I want to do is I'm going to go back and I'm going to clear all of this out. I'm going to clear my nodes, clear my channels, and clear my packet buffer. And what we're going to do is we're going to change this such that we are scanning channel 36. Okay, so you can see that channel 36 is being monitored, or we're going to capture on that channel. And I'm going to start the capture, but first I'm going to get some data communications going. So let me start that. So I'm simply on a different computer right now, starting a file transfer. And that is going to give us the ability to capture. So I'm going to go ahead and start the capture now while that transfer is going. And you can see now this NETGEAR device. That NETGEAR device is the station that's transferring the data. You can see the richness of our spectrum in the lower part there as it is glowing more. Why? Because we're utilizing it, right? So we're actually transmitting some data, some information is being sent. And so I'm just allowing this to capture some data because we actually want to be able to take a look at some of the data rate information and things like that that's available to us from this. So I'll let it run for just a few more moments. Okay, I have canceled the file transfer. Now this is not any kind of a throughput test because we were just accessing an internet file. And so what we're going to do now is stop this. And let's take a look at a couple things. First of all, if I double click on the Belkin here, just to show you another area of this particular application, I can see its max rate is 1300 megabits per second, max power 17 dBm, and that it's a 3 spatial stream device. You can already see some data rates down there involved in the communication. If we go into the NETGEAR, we see some data rates as well. So here's an important thing I want to talk about with 11AC. So we see a data rate here of 702 megabits per second. Here's the question. Can that tell me anything? Just the fact that I've seen a 702 megabits per second communication, does that tell me anything? Well, the answer is it does. It tells me immediately with 2 background pieces of information, my knowledge of what's available as far as hardware and the knowledge of how 802.11ac works. You bring those 2 things together and immediately I know I have an 80 megahertz channel going on here. I also know that it's a 2 spatial stream client. Okay, so how do I know that from the fact that I see a 702 megabit per second data rate? Let me show you. I'm going to pull up the 802.11ac standard document. And we're going to search in here for MCS. And just tap F3 a couple times. Okay, so here we are. Table 2230 is where it starts. And these are your MCS tables. So looking at the table for 20 megahertz with 1 spatial stream, the highest possible data rate with a short guard interval is 86.7. So there's no way that it's a single spatial stream 20 megahertz device, is it? What about 2 spatial streams 20 megahertz? 173.3 is the maximum. So there's no way that's it. What about 3 spatial streams 20 megahertz? 288.8. I'm sorry, 288.9. So 288.9 is the maximum data rate of 3 spatial streams at 20 megahertz. So I immediately know it's not a 20 megahertz communication, don't I? So if we go down further, we know, by the way, in the industry right now, we know we don't have 4 spatial streams, so there's no need to look anymore at 20 megahertz. So if I go further in my tables and I get to my 40 megahertz table, okay, 1 spatial stream, maximum 200 megabits. 2 spatial streams, maximum 400 megabits. So I know it's not a 40 megahertz channel at 2 spatial streams. What about 40 megahertz channel at 3 spatial streams? Maximum is 600 megabits per second. Now let me ask you another question. Do we have anything that's greater than 3 spatial streams in the market right now? No, we don't, do we? So I immediately know it's not a 40 megahertz channel. Now this is how I said, knowing it's a 702 megabit per second data rate allows me to also know today, right now, that it's an 80 megahertz channel. So when we take a look further, do we see a 702? Well, not yet, not at 4 spatial streams. There's no 702 there. What about at 5 spatial streams? No 702 there. 6 spatial streams? No 702 there. How about 7 spatial streams? No 702 there. 8 spatial streams, no 702 there. Okay, so it's not a 40 megahertz channel. Let's look at 80 megahertz. Here's my 80 megahertz, one spatial stream. Only goes up to 433, so I know it's not one spatial stream. Here's 2 spatial stream, 80 megahertz. Look at that. What do you see for the first time right here? 702 megabits per second. Okay, so this is likely a 2 spatial stream client using the standard or long guard interval. That's likely what it is. Now, I say likely because watch this. If we go up to 3 spatial streams, we see we can get 702 megabits per second with 64 QAM. But I happen to know it's not a 3 spatial stream client. Okay, so I know that's not what's taking place. I also know that it's about 9 or 10 feet from the access point. And so therefore, I know that it's able to get higher modulation. So here's an interesting thing I can see from this. If you take a look, here's my 702 megabit per second data rate. So I know that I'm using 256 QAM as well. So this is a 256 QAM connection, 3/4 coding, and that's how I got the 702 megabits per second data rate. Okay, so I just wanted to kind of walk you through that to let you know that just the moment you see this data rate of 702 megabits per second, that actually tells you something. It tells you something about the communication. Okay, so then if we go back over to our packets, we can see the different packets that are there. Now, the only thing we're actually really capturing and looking at is the management data frames, or the management frames. We're not really storing in the buffer the actual data frames themselves because we didn't turn that on. So you can see then some of the information we can get through protocol analysis this way. And because I want to make sure we get the chance to look at the remote AP capture, let's go ahead and take a look at that now as well. So what I'm going to do is close down Commview for Wi-Fi, and it gives my Wi-Fi adapter back to the local machine, though that's not really all that important to us for what we're doing right now. I'm going to go into Internet Explorer and go to my Cisco AP. So this is the Cisco AP I mentioned. That is the WAP371. Okay. Again, this is your small business category of devices from Cisco. And first thing you can do is you can go into wireless and the radio, and you can set it to the channel and the frequency range. So what I'm going to do, for example, is I'm going to put this down on 36 and have it look where I know that network is that we were just looking at. And now, of course, we can change supported data rates and all the rest of that. So we'll go ahead and add back in our data rates to support these. And let's go ahead and save this. Now that's going to make that active for a moment. The thing is, you need to configure the radio in this particular device to the channel that you want to monitor. And then after you configure the channel that you want to monitor, go to Administration and Packet Capture. And then right here, you can either just capture the packets right here immediately, just off of Radio 1, or you can set it to be available for remote packet capture. So if I say that, and then I click Save, and I'm going to click Start Capture, then I can do remote packet capture with that. And I could use Wireshark, or I could use Commview for Wi-Fi. So for example, if you go into Wireshark and you go into your interface list, I'm going to say that I want to create a new remote interface. And we're going to say it's 192.168.10.250. 2002. I don't know if you noticed that or not, but that was the actual port that it's listening on. So I'll click on OK, and you can immediately see it finds everything that's out there. And I'm going to hide everything except for the radio. And we'll close that down. And so now you can see right there, there's my RP cap. So I'm going to do a capture on that. And you can see right there, it's capturing my data. So I'm seeing all of those beacon frames. I'm seeing the Belkin show up. That Belkin, remember, is my Linksys device. So I'm just going to let it capture for a second here. And all right, now we'll stop it, and let's go ahead and save this. We'll put it on our desktop, and we'll just save it as a PCAP file. Call it test2. And so, yes, we can look at information right here. So I can look at a beacon frame right here in Wireshark. and I can see the radio tap header and any information that might be provided. So I see the noise, I see the signal, I can get that information. But now that I've captured it with remote capture there, I could open that up in something else. So if I right click on it, I can open it, for example, with Omnipeek. And so here we are, it's pulling in our data, and there we go. So we're looking at our data. If I go to my network, I can actually see all of my statistical information that you would typically see in Omnipeek that you might want to look at. If there's voice going on, you could see that. You can use Compass for your analysis here. My point is not to teach you how to use Omnipeek. I'm assuming if you use it, you know how to use it. If you use Commview for your Wi-Fi, you know how to use that. If you use Wireshark, you know how to use that. My goal is to show you how to get 802.11ac packets, okay? How to actually do that kind of thing, and then what you can see in them. So here are my packets, and if we take a look in here, scrolling down a little bit, we can see all of these different packets that are captured. We can see a lot of the 11N packets there. Ethernet broadcasts. Here's your beacon frame. You can see that it is a beacon. And if we move this out, we can see right there's my Linksys, right? So if I double click on that and look at the header information here, I can see the actual channel that's being utilized. I can see information from the beacon frame. If we scroll on down in the list, we'll eventually get to our VHT section. So I just want you to see that it's here. No, the Omnipeek does not recognize the Edimax at this point in time. Okay, here's my VHT capabilities. And one of the things that a lot of people like about Omnipeek's decode is it does give a little more information down through here about what all this stuff is. Little further extrapolating the explanation really is what it's doing for you. So we can see, for example, what is supported, what is not supported. It's all the exact same data before though, right? So we can see our spatial streams that are supported. So MCS index for 1 SS, notice this one says 2 and 3, so here it interprets as 1 through 8 instead of 0 through 7, but it means exactly the same thing. And so we can see the information here for the spatial streams and the MCS rates. And remember those MCS rates, that's the tables we looked at. Remember we went into the standard, we looked at the tables, we saw how in the world do we get to a 702 megabits per second data rate. So that's what we were looking at there. You can see that I can do this packet capture in that way, much like I can with Commview. So even though Omnipeek may not internally support the adapter, if I have the Cisco AP, I can use that AP or some other AP that does remote packet capture, do the remote packet capture with Wireshark, which is free, pull it into Wild Packets. Wild Packets does also support remote capture from many APs built right in. As a review, what did we look at? We looked at the adapters that can be used, we looked at the software that can be used, and we looked at protocol analysis with an AP. Now, one of the things I always like to try to help you with is when you're trying to build a lab to do your own learning and things like that. Now, first of all, let me say our current CWAP certification, which would be heavy on analysis, does not test on 802.11ac. Okay, so CWAP does not test on 802.11ac today. It certainly will once it's updated. So it's very important to keep that in mind. If you're trying to build a lab, it's always good to know how can I build a lab that can give me tools so I can actually do some of this stuff. So the Cisco WAP371 is a great device to have just for your lab anyway. It's an 11AC 3x3x3 inexpensive device. You can get it for under $300 online. And so that's not, in my mind, that's not all that expensive for an AP that gives you the features that it provides to you. And so you can use it to do remote packet capture, things like that. So that can be very useful. Also to have in your arsenal, Wireshark, and then you can get Omnipeek, Commview for Wi-Fi, Airmagnet Wi-Fi Analyzer, which we didn't actually look at today, or any of these. But then whichever one seems to meet your need would be a good purchase if you're going to work in the Wi-Fi industry, that's for sure, to have something like that, and hopefully your employer will help you with that. But if you're learning on your own, remember, you can do wireless analysis, look at frames, look at radio tap headers and other such information inside of Wireshark if you have the right capture tool set, the right things to do the capture for you. And so that's the big key. So remember the Cisco WAP371 today, Edimax adapter is a good choice if you want to capture using Commview for Wi-Fi. Remember, that adapter does not work in Omnipeek, but we can do the capture in Wireshark and then save it as a PCAP and load it right up in Omnipeek and take a look at all of that same information. So at this point in time, I'll just leave it open for any questions you might have for the next few moments. So if you want to type in any questions that you'd like to ask, I'll make sure and answer those.